Welcome to the MAHLE Powertrain Tech Talks, and I'd like to welcome Gareth Cummins, our Principal Design Engineer of 25 years at MAHLE Powertrain. And today we're going to talk about the pros and cons of cell form factor for battery technology, and also battery pack design for legislation. And Gareth has been one of our design engineers for a long time, looking after some of our recent battery development projects. So, Gareth, I want to ask you, what is the main driving trend towards the larger form factor for cylindrical cells?
I guess first thing is the gravimetric energy density, so the amount of energy you've got for the weight of the cell. The bigger the cell is, the more of the active material you've got inside and less of the can on the outside. So that could lead to up to sort of 16% improvement in your energy density in your whole pack. There's also new manufacturing techniques which are being developed which are helping to fill those bigger cans, and you've got opportunities for what they call a tabless design, which will potentially give us more or less internal resistance and more power from each of those cells.
Okay, right. So what are the main advantages of using a cylindrical format cell over a very high performance hypercar or BEV vehicle?
So again, that comes back to the gravimetric energy density. So with the cylindrical cells, you can pack lots of those small cells into a relatively small area. They might not be quite as good as pouch cells, but you don't need then a whole additional structure to mount and stop the swelling of the pouch cells. In terms of volumetric energy density, so that's the mass relative to the size of the cell itself. The prismatic cells are slightly better in that regard, which means you would get more range, but in a sports car the range is not seen as quite as important as the power that you can get from those cells.
Okay.
Yes, that's definitely one of the reasons. Smaller cells can mean you've got lots of connections in there, which can make them a bit expensive, but again, with a sort of low volume, high performance car, that's not so much of an issue.
Okay. So prismatic cells were often perceived in the past as an inferior option.
Yep.
Where are they now, and looking at increasingly utilised in many OEM packs?
Yeah, so historically the prismatic cells have effectively been a squashed cylindrical cell, so they're sort of wrapped on top of each other, which meant in your square case,
okay,
you had sort of 4 empty corners which didn't have anything in, so they were just wasted space. Whereas new techniques they've developed for manufacturing and mean that you can now sort of fold the active layers together, so effectively you've got more like a pouch cell. It's just in a hard case rather than a soft case, and that hard case gives you benefits in terms of structure, especially with now the move towards away from sort of having separate individual modules and going and putting the cells directly in the whole pack or directly in the vehicle. It allows you to squeeze everything a lot closer together and still have some structure which is formed effectively by the case of the cell itself.
So improving the energy density of the pack, really.
Yeah, absolutely. Yeah, you get more energy in and squeeze everything tighter together. So
how's the mechanical design of the battery pack affected by the different aspects of legislation at the moment?
Yeah, so the main sort of testing regime that's done in Europe is the R100 test. That there are similar ones in the US and China. But yeah, there's sort of 3 main categories, I guess, in terms of testing. So there's sort of vibration, thermal shock, mechanical shock, and mechanical integrity, which is all to do with sort of the strength and stiffness of the battery pack itself and sort of its performance in crash, making sure you don't get any damage from that or from road loads and vibration, that sort of thing. Second one is sort of fire resistance, so external fire resistance. So if you have a hybrid vehicle, you've still got an engine and a fuel tank in it, and potentially you can get fuel spills and things underneath, so you want to make sure if you get a fire outside of the vehicle, it's not going to sort of overheat the battery pack or overheat the cells and cause a thermal runaway in the pack itself. Third group is things like external short circuits, overcharging, over discharging, over temperature, things like that, which from a mechanical point of view, it's more about putting sensors in the right place and measuring the voltages so that you can then feed that into the control system, and that's probably more of on the electronic side of measuring what's going on and making sure that you can shut things down when you need to.
So what's the main conflicts then between increasing requirements for integration and packaging efficiency of battery packs and recycling legislation?
Okay, so one of the things that you get with most of the ways the packs are manufactured at the minute is the highest performing way of joining cells together is to weld something in between them. And obviously when it comes to welding, that makes, especially if you've got 6,000 cylindrical cells or something all welded together, or the tabs all welded together, that can make it pretty difficult to recycle. You've got to effectively get rid of every single one of those welds. The other things you get is, as you said before, the bigger the integration into the vehicle and the pack itself, we're looking at sort of structural adhesives and things to glue things together rather than having lots of mechanical fixings and things like that. And when it comes to adhesives and gap fillers and things, obviously you've got to try and separate those out from the things that you might want to recycle, the cells and any additional structures that you've got in that battery pack. That just makes it much more expensive. Potential for few mechanical fixings and things like that, but then you're sort of looking how do you maintain all your sealing and your performance. If you get thermal runaways and things, you've still got to maintain the integrity of your pack.
Yeah, okay. That's great. Thanks very much, Gareth. I appreciate your time today. If you want to know more about battery pack design and you want to get in touch with either myself or Gareth, contact us at MAHLE Powertrain.